This is Higher Maths, it's PaperD, it's the non-calculator paper, and it's question 22 that we're looking at here. Okay, we've got P is this point, Q is this one, R is this one here. Show that P, Q and R are collinear. 3 marks for this one here. Okay, so what I'm going to do is I'm going to work out the component vector of PQ, then the component vector of PR. I've used a common point of P, and I'm hoping that the component vectors are the same to make it collinear. If they're not, then the points are not collinear. Let's go ahead and do that one first of all. Right, so we'll go for the vector PQ, and what we'll go for there is I'll take the position vectors and subtract them. Okay, so Q is 520, and P is 4, 1, minus 2, and what we'll get there is 1, 1 and 2. Okay, so there's the first component of PQ. Go for the components of PR. Now you could have used a different point, you could have used QR and worked it out from there, which might have been a better option, but we'll just go for this one here just now. So that's R minus P, and we'll go for 744, and I'll go for 4, 1 minus 2 for P. Taking that out, that should give me 3, that'll be 3, and that'll give me 6. Okay, and what I can see here is there's a common factor of 3, so what I can do is I can take that out, it's a common factor, 1, 1 and 2. And what I can see now is that this component here and this component here is the same. One of them is just 3 times as large. Right, so what I'm going to do is I'm going to write this down just as a basic fraction or a basic kind of ratio type thing. So what I've got is I've got PQ, which is equal to 1, okay, and PR is going to be equal to 3 of them. So therefore what I can see is just by cross multiplying 3PQ is equal to 1 PR. Okay, so with this statement here, what I can say is that PQ and PR are parallel. I'll just say that a common point, and the common point that we used was P in both of these. Common point P has been used. Therefore, I'll say that P, Q and R are collinear. That's the end of part A. Right, for part B, what we have to do is we have to find the ratio in which Q divides PR. So let me just draw the line of what I would think that should look like. So I know that I've got from here, so this will be the point P, okay. If I move along from here, just go along this size here, just another one, and there. So I know that this will be R along at the end here, and I know that P to Q is going to be here, because that's 1 and that's going to be 3. So 1 there, 3 there, okay? So this size here will be 1, and between Q and R would be 2. Okay, so from there, what I'll do is I'll just write down PQ all over QR. It's going to be equal to 1 to 2. And that's really just going to be my ratio. So the ratio, show Q divides PR, is, and it's just going to be 1 to 2, as written out as a ratio. Right, let's see the marks. We've got 4 marks to be gained here. So we'll go for 1 mark for getting this component vector. I'm going to go for 1 mark for getting this one here. For making this statement, all of this here would be the final mark. That's the final mark there, so that's 3 marks for part A. And just working out what the ratio is, so the ratio is a 1 to 2 ratio. Marks for this question here, out of 4.